Welcome to the second video of Modern Tacheometry aka Detailing Survey. In this video, we are going to learn the planning of tacheometric survey. Before any detailed surveying fieldwork is undertaken, the first task is to prepare a set of specifications which set out the aims of the survey, the accuracy required, the amount and type of detail that is to be located, and lastly is the intensity of any spot levels that are to be taken. This information is necessary in order that suitable equipment and techniques can be chosen to ensure that the aims of the survey can be achieved. Careful planning is required in order to ensure that the accuracy and aims of the survey can be established before any fieldwork begins. This calls for the preparation of a survey specification in which the various requirements are listed. Next is the accuracy requirements. The accuracy requirements of a proposed detailed survey are governed by several factors. In particular, the required scale of the finished plans, the minimum size of detail that needs to be included, how is it to be represented, and the accuracy to which it can be plotted. Alright, let's stop here and revise a little bit. Let's talk about scale for a moment. Now, two scales. One 500, one is to 500, and another is 100. Which one is bigger in area? Guess what? Of course, 1 is to 500 because 1 mm on plan represent 500 mm on the ground, while 100 means that 1 millimeter represents 100 millimeter on the ground. So which one is bigger? Of course, 500. But if the size of the paper is the same, let's say these A4 papers, then the next question is which features appear bigger? Of course, features in 100 will appear bigger in the A4 paper. Okay, to understand further, let's exaggerate a bit and imagine it. Set the unit to centimeter with 1:1 scale. A feature, let's say a circle drawn with 1 centimeter diameter on an A4 paper represent 1 centimeter diameter on the ground. This is 1:1 ratio or scale. Feature on paper is exactly the same size as feature on the ground, 1:1. Let's change it a bit. 1:10 scale. 1 centimeter on A4 paper represents 10 centimeter on the ground. Means the feature on ground is now bigger than the drawing. Okay, let's go further with 1:100. Means 1 centimeter on paper represents 100 centimeter on the ground. Now back to the previous discussion. Compare it to 1:500 ratio or scale. 1 centimeter on paper means 500 centimeter on ground. Remember, basic of scale is that it has no specific units. Therefore, the ground area represented in 1/500 is larger than 1/100. Okay, the area represented. But the features drawn in 1/500 drawing plans is smaller than 1/100. Okay, let me repeat. The features drawn in 1/500 drawing plans, okay, the scale is smaller than 1/100. Alright, next. Survey drawings are not always what they seem to be, since it is a simple task, especially for a computer, such as to enlarge a section of a detailed survey drawing originally produced at a scale of 1/500 and plot it at a scale of 1/100. However, unless the original site measurements were taken to an appropriate accuracy, the enlarged section will be inaccurate. It is generally considered possible to plot a point on a sheet of paper to within millimeters measurement, such as 0.2 millimeter. This means that the accuracy in millimeters of any point plotted on a survey drawing is normally given by the scale of the drawing multiplied by the factor, the 0.2 For example, any point shown on a 1/100 scale drawing should, in theory, have been plotted to an accuracy of at least 100 multiplied with 0.2 millimeter. That is at least 20 millimeter or 2 centimeter. However, in practice, this will only be the case if the survey measurement were taken on site to an accuracy of at least 20 millimeter. If they were only taken to an accuracy of, let's say, 100 millimeter, then the maximum scale drawing that can be produced, which will meet the 0.2 factor of plotting accuracy criteria, is 1/500, since 500 times by 0.2 millimeter equals to 100 millimeter. In such a case, if a larger scale than 1/500 is required and measurements were only taken to 100 millimeter, the drawing will be in error, since the plotting accuracy is greater than the accuracy to which the measurements were taken, and it becomes impossible to plot the points in their correct positions. This problem can occur when an area of a site originally surveyed to an accuracy suitable for one scale is plotted at a larger scale, which can easily be done in computer-aided mapping, of course. For this reason, it is absolutely vital that the original survey measurements are taken to an accuracy suitable for their intended use. Unless this is done, subsequent plotting scale enlargement will cause errors in any distances or positions scaled from the enlarged drawing. Ideally, wherever possible, the accuracy to which the survey measurements were taken should be quoted on any drawing produced from them to alert the user to this possibility. By them, I mean the surveyor. Let's imagine it this way. A camera resolution. Okay, simple. A camera resolution, everybody knows this. Lower resolution image or smooth skin filter effect that you apply may also capture the blurred pimple on your selfie. Now, if someday in the future someone claims it is possible to increase the resolution of an image, give them your selfie image and ask them to pinpoint the exact spot of the pimple. This is impossible and cause inaccuracy. Okay, it is not accurate at all. Similar to these plotting cases. Okay. Next, when choosing a measurement accuracy, a good compromise can normally be achieved by recording all distances where possible. to the nearest 0.01 meter or 10 centimeter or 1 centimeter. This should enable the subsequent production of a larger scale plan of a particular area of interest to be achieved without loss of accuracy. For contours, the vertical interval depends on the scale of the plan. Usually, the accuracy of a contour is guaranteed to 1/2 of the vertical interval. All spot levels taken on soft surfaces, for example grass, should be recorded to the nearest 0.05 meter or 5 centimeter, and those taken on hard surfaces must be nearest to 0.01 meter or 1 centimeter. In areas where there is insufficient detail at which spot levels can be taken, a grid of spot levels should be surveyed in the field and plotted on a plan. The size of the grid depending on the scale. Other factors to be considered when specifying the accuracy of a detailed survey are minimum size of the detail that is to be included on the drawing and how it should be represented. Depending on the specified plotting scale, it is not always possible to plot small features at their correct scale size, the size at which they appear on a drawing, and they may have to be represented by symbols. In practice, how the detail is to be represented actually depends on the resolution of the drawing scale. Normally, any point can be drawn at its correct scale size. If it is larger than 1 millimeter at the plotted scale, for example, a square manhole having sides of length 1 meter can be plotted at its correct scale size on a drawing having a minimum scale of 1/1000, since 1 millimeter times 1000 is equals to 1 meter. If the survey is to be plotted at a smaller scale, let's say 1/5000, then a symbol should have to be used to represent the manhole, since the scale is too small to show it its correct scale size. Next is the amount and type of detail and text to be included. In addition to accuracy considerations, it is necessary to decide on the amount and type of detail that is to be located, the intensity of the spot levels that are to be taken, and the amount of text to be included on the finished plan. This decision depends on the number of factors. First is the topography of the site will influence the number of spot levels. Frequent steep undulation requires higher number of spot levels. Secondly, the purpose of the survey will dictate the type of detail to be located. For example, for civil engineering design work, contours on natural surfaces, spot heights, and all naturals and man-made details should normally be shown, including overhead detail such as telephone cables and power lines, and where possible underground detail such as water pipes and sewers. Thirdly is the time available for the work may restrict the amount of detail that can be located. Next, at the fourth factor is the intended use of the survey will influence the amount of text to be included on the finished plan. This is particularly important in surveys where there is a high density of detail, which may become very cluttered when text is added. What may appear clear when zoomed in on a computer screen may appear very overcrowded when printed on a sheet for use on site. To avoid this problem, the amount of text included should be tailored to the intended use of the survey and plotting scale chosen accordingly. A larger plotting scale will give more space for text but will produce more drawings, and the effect of enlargement may result in errors in distances and positions scaled from the plan as discussed in the previous section. A smaller plotting scale may limit the amount of text that can be included, but will enable the survey to be produced on a smaller drawing, making it easier to use on site. In addition to the above, one very important factor that can have a considerable bearing on what is shown on the finished drawing is the budget available for its production, of course. Since greater detail requires a greater amount of work and higher accuracy requires more expensive equipment, a survey which requires high accuracy and intensive detail will be more expensive to achieve. Alright, with that, we end this video, and if you have questions, please email it to me. Thank you and see you in the next video.